This class is Physics 124. Physics 124. And in this Physics 124, we are going to be talking about Gauss law. Gauss law. You know that this is exam time, so we need to simplify everything as soon as possible. So under Gauss law, first of all, we can't understand Gauss law because we need to understand the concept of electric flux. So we are going to be defining what is an electric flux. Are we getting it now? So what is an electric flux? Electric flux is the number of electric field lines passing through an area. So we say that electric flux is equal to the number of electric, I get it now, the number of electric field passing through an area. So we say phi is equal to AA. Now what if this is inclined at an angle? So that means this will be phi to be equal to EA cos theta. Are we getting it now? So this is the first formula you should know under electric flux. Now, under this formula, there are three cases. First of all, let's take a surface. And let us imagine that the field. Now, first of all, if you move perpendicular from that surface, are you getting it now? There is a vector called the normal vector. The normal vector is perpendicular from that surface. Now, when we have electric field lines passing through the surface, what does it mean? From here now, the electric field lines, if you observe it in a clear dimension, you discover that the electric field line is perpendicular. It's perpendicular to the surface. Are you getting it now? And parallel to the normal. Now, this angle between the line and the normal is what you will use as your theta. Listen very carefully in case they give you an exam. So that becomes phi equal to EA cos. Are you getting it now? Cos what? Now, since it's parallel, it becomes what? 0. Are you getting it now? So that becomes EA cos 0. Remember that cos 0 is 1, so that will be phi equals to EA. It means that when the flux is parallel to the normal of the surface. How do you know normal of the surface? Just point out a perpendicular direction from the surface. That is the normal. So when the flux is normal to the surface, are you getting it now? Flux is equal to EA. Now, the next case we'll talk about is when the flux, are you getting it now, is parallel. When the flux is parallel. When the flux is parallel to the surface, something like this. Are you getting it? But perpendicular to the normal. This is the normal. Because when the surface is like this, the normal will point out. Now, the flux is perpendicular to the normal. What will be E? Flux, phi, will now be, this is field, sorry. The field is perpendicular to the normal. Phi will now be A cos 90. Are you getting it now? And that will be what? Equal to 0. Because cos 90 is equal to 0. Now, the third case is when it's acting at an angle. When the flux is at an angle to both of them. So we use phi to be equal to A cos theta. So depending on the question you are being given, those formula, the main thing you just need to know here is this. So number 2 and number 3 can come up in OBJ. Number 2, the other one can come up in OBJ. Now let's talk about Gauss law. What is Gauss law? Gauss law states that, are you getting it now? Gauss law states that the electric field passing through an area is equal to the charge enclosed, Q enclosed, are you getting it now? Enclosed, divided by the permittivity. So it means that the electric field passing through an area, E, is equal to charge enclosed over permittivity. We already know that E, are we getting it now? Sorry. Sorry, the number of fluids passing through an area, it's not the charge, the number of fluids passing through an area is equal to the number of charge enclosed over the permittivity. We already know that flux is equal to what? F is equal to feed times area. Now, everything here talks about Gauss law. So I'm going to be giving the application of Gauss law. In the next class, we'll be solving a lot of problems, but now I'm just going to be giving some shortcuts. The application of Gauss law, the first application is point charge. First one is Gauss law to point charge. Gauss law to point charge is given by 4 pi kq. I get it now? Gauss law to point charge, it means phi is equal to 4 pi kq. Also, this phi can be equal to can be equal to feet times area. Number 2, Gauss law through a Gaussian surface is equal to 0. Electric flows, I get it now? Electric flows through a Gaussian surface is equal to 0. Why is it equal to 0? Because the surface is not enclosing any charge. There must be charge enclosed by the surface. So see, if the surface is not enclosing any charge, it means that the charge passing through the surface must be equal to what? The charge leaving the surface. So there is no charge contained in that surface. So it will be equal to what? 0. And the third one here, I have summarized it. I will send the PDF if you want. The third one here is electric field of an infinite line charge. Number 3, electric field of an infinite line charge. Electric field of an infinite line charge E is given by lambda, are we getting it now? 2 pi arrow times permittivity. Now, this lambda is called line charge density. This lambda is called what? Line charge density. Line charge density is defined as charge over length. Line charge density is defined by what? Charge over length. While epsilon is the number of free space, arrow is the length of the conductor. Is the radius of the surface of the conductor. Don't worry, when we begin to solve problem under this, we'll begin to get more of the application. Number 4, I think this is the summary of Gauss law, is field of an infinite plane sheet. Field of an infinite plane sheet of charge. Make sure you are writing those things down. It's given by E is equal to sigma all over 2 epsilon. Now, what is sigma? Sigma is called area charge density. It's called area charge density, which is charge over area. Now, the unit for sigma is meter cube. Is coulomb per meter square. While this one is coulomb per meter. Now, when you know those formula, there is nothing you can't solve under Gauss law. There is nothing. Don't worry, in the next class we'll begin to solve problems that are related to Gauss law. But I just want to give you the summary of everything. So let us recap everything that we have been talking about under Gauss law. The first one is electric flux. Electric flux is the number of electric field lines passing through an area. Are you getting it now? And it's given by what? Electric field times area. That is flux. Now, what if this flux is inclined? If this flux is inclined, it's called EA cos theta. Now, this theta, you should know that it is the inclination of the field with the normal of the surface, not the surface itself, the normal of the surface. And I told you that the normal of the surface is bringing out a perpendicular line. If you need more explanation, you can put it on the comment section below. Bringing out a perpendicular line from the surface. So how it's inclined, how the field inclined with this surface? will give you your theta. Now the first case was when it is what? At parallel to the surface. When the field is parallel to the surface, that means there is no angle, that is 0. So that will be cos 0 is 1. That will be what? Field times area. Those things are exam OBJ. They come out most times in the exam OBJ. What if it is perpendicular to the normal? When it's perpendicular to the normal, like you see the surface now, I getting it? Just doing revision. When you see the surface now, this is the normal, and the field passing through is now perpendicular to the normal. What will you do? How do you get your angle? You look for the inclination between the field and the normal, and this case now is what? Angle 90. So that becomes EA cos 90, which is what? 0. So it means that the only way flux will be 0 is when the electric field is perpendicular to the normal of the surface. Now, what if it is an angle? An angle. So when it's at an angle to the normal, we use EA cos that angle. Very easy. Now the next thing we talk about was Gauss law. Gauss law states that the number of flux, this is electric flux given by phi, passing through a surface, are you getting it now, is equal to this charge enclosed by the surface all over the permittivity. So this is Gauss law. How we got EA was that we already know that phi is equal to EA. So since phi is equal to this, that means that phi will also be what? Equal to EA, depending on the question. Now we now apply Gauss law to point charge. We don't really need to do the calculus derivation. Just know the formula and you are good to go. So the first one was phi equal to 4 pi permittivity constant times charge. So this is applied to point charge. Don't worry, we will begin to do more of this when there will be problem in the next one. So now, when point 2 is when the field is passing through this. When we got 0, when the field, if the field is passing through, for the marker, when the field is passing through a surface or an enclosed conductor, yes, when it's passing through an enclosed conductor or a Gaussian surface, when it's passing through a Gaussian surface, the number of charge, I get it now, the number of electric flux will be equal to 0. Why will it be equal to 0? Because there is no charge enclosed. Gauss law talk about charge enclosed. So if there's no charge enclosed here, it will be equal to 0. Because the number of charge passing through will be the number of charge going out. There will be no charge stored because the charge comes from what? A point charge. The number of flux will come from a point charge. Then the number 3 is electric field of an infinite line. The formula for electric field of an infinite line is given by E is equal to lambda all over 2 pi arrow over epsilon. If you just know this one, you are good to go. Now your lambda is called linear charge density. And linear charge density is charge all over the length of the conductor. Make sure you understand it. Don't worry, when you talk problem of this, you understand more. And this one is field of an infinite place sheet of charge. In this case now, your electric flux is equal to sigma all over this sigma all over 2 epsilon. Where sigma is called what? Where this is called area charge density. Thank you very much. Make sure you watch this over and over again. This is the simplification of chapter 3. Chapter 3 of your physics 1 to 4. The next class, we will solve problem of this. I will begin to move to chapter 4, which is called electric potential. Thank you very much. God bless you.